So now that we've studied points, let's investigate how to figure out the midpoint between 2 points. So if you have 2 points on a graph, how do you figure out what that middle point is? For example, and this is kind of complicated looking at first, but let's say we have a point over here, this blue point. We're going to call it x. We're going to call it well, let's just call it the blue point for now. We have a point over here, our red point. Imagine any 2 points on a graph, we're going to have a point in between. The question is, how do we figure out what that midpoint is? Well, as you can already kind of see in this illustration, first of all, this point has an x value, we're going to call it x1, and this point has an x value, we're going to call it x2. We can see that the midpoint must have the middle of these x values. In other words, the middle of this orange dotted line. In the same way, this blue point has a y value, we can call it y1, and this red point has a y value, we can call it y2. The y value of the midpoint would also be the average of the y values, namely y1 plus y2 over 2. So the x value of the midpoint is the average of the x values, x1 plus x2 over 2. The y value of the midpoint is the average of the y values, y1 plus y2 over 2. So what does that mean? That means we can figure out the midpoint of any 2 points using this illustration. First example, find the midpoint between the points 12, 4 and 8, 3. This is very important. Always label your points. I tell my students this when we draw a line, when we find the slope of a line, which is another lesson. Anytime you're dealing with points and you're solving something, label them. And usually you're going to label your first point x1, y1 and your second point x2, y2 just based off the order in which you were given them. So the first point I'm going to label x1, y1. The second point I'm going to label x2, y2. So that way we're consistent. That way, yeah, just basically for consistency's sake. Then we're going to write out the formula for the midpoint. So we just figured out that the x value of our midpoint must be the average of the x values of our 2 points we're given, namely x1 plus x2 over 2. The y value of our midpoint is going to be the average of the y values that we're given, just like we saw here, and that's namely y1 plus y2 over 2. So step 2 is to write out the formula. Again, be consistent. Always show your work. Much more likely to get it correct that way, less likely to make a mistake. Then you're going to plug in those values, and I wish I would have done this on the same page, but x1 we're going to just plug in for 12 because that's what we got when we labeled our point. X2 we're going to plug in for 8, which is our second x value, which we got here, and so on and so forth. Plug in our y1 and y2 values. From there we just solve, okay? So 12 plus 8 is 20, and 4 plus 3 is 7. So that's what we get right here. And when we simplify it out, decimals are better than fractions when it comes to points. They're easier to sketch or to plot. So final answer is 10, 3.5. So 10, 3.5 is the midpoint between these 2 points. And you can kind of see it's the average of the x's and the average of the y's. Example 2. Find the midpoint between the points -11, -4, and 1, 8. So we're going to label -11, -4 as our x1, y1. First point we're given. Second point we're going to label x2, y2. We're going to write out our formula, and that's not working out. Okay, let's try this again. So here's our formula for midpoint. X1 plus x2 over 2, y1 plus y2 over 2. Then we're going to plug in the stuff we just labeled. So we labeled our first point x1, y1, and our second point x2, y2, and we're going to plug this into the formula. And don't know why I have that written down there. So anyway, here we go. Here's our x1 plugged in. Here's our x2 plugged in to that formula. And then here is our y1 and y2. And we are going to then solve that. So what's -11 plus 1? That's -10, right? -12. -4 plus 8 is 4. So we have that. And then simplifying that, negative 10 over 2 is negative 5. 4 over 2 is 2. That is going to be, might as well write m equals, right, because that's our midpoint. So we found that to be our midpoint. Negative 5 comma 2 is our midpoint between negative 11, negative 4, and 1 comma 8. Alright, example 3. Find the midpoint between 11, 5 and 11, negative 5. We'll go through this one pretty quick. Here we have our points labeled x1, y1, x2, y2. Again, it's the same exact formula we've been using. It's not like the formula changes. That's always the midpoint. When you plug in our x and y values, x1 plus x2 over 2, y1 plus y2 over 2. In this case, what I want you to see is, 5 plus negative 5 is 0 over 2, which just gives you 0 on top. And for x values, notice, our x values that they gave us are both the same. The average of those is still going to be 11, right, if it's the same. So we get 11 plus 11 over 2, comma 5 plus negative 5 over 2. 22 over 2 is just 11, and 0 over 2 is 0. That's going to be our midpoint. Okay, so the midpoint between 11, 5 and 11, negative 5 is 11, comma 0. And if you were to sketch these points and look at them on a graph, in fact, let's do that. Let's see what that would look like. Just a real quick sketch, 11, 5 and 11, negative 5. I'm just going to draw some kind of axis here. So 11, 5 would be somewhere up here, and 11, negative 5 would be down here. And so you can see visually that the midpoint would be at 11, 0. Okay. Sometimes it helps just to graph these, just to visualize what we're trying to find. So here in the middle would be our midpoint. And of course that line would be a vertical one if we connected them with a line. Alright, so here's an example we came up with in class. I'm going to have to go back and forth a little bit. So we're going to read this word problem. Actually, no, we didn't. I thought I had the word problem typed up. I guess not. Oh, yes, I do have it typed up. Okay, so then we'll go back and look at the graph. Reno is 248 miles west and 232 miles north of Las Vegas. Okay, so we can kind of visualize it has you go over some way and up some way. And actually, let's go back and see. Okay, so you're going, what did it say? 248 miles west and 232 miles up to Reno from Vegas. And again, you kind of have to go down to see that. 248 miles this way, and then 232 miles up to get to Reno. And I never actually, looking at this, I never realized Fresno was due south of Reno. Pretty crazy. Anyway, so you can imagine that Reno then would have a point negative 248, 232 from Vegas, if we label Vegas as 0, 0. So here's a practical illustration where we're using a map. Alright, so Las Vegas has a starting point 0, 0 and Reno negative 248, 232. Alright, so suppose Tonopah is halfway between Las Vegas and Reno, and suppose Hawthorne is halfway between Tonopah and Reno. So going back to the map, let me just basically show what we're saying here. So let's just suppose that this point right here, Tonopah, is halfway between. And then we want to, then the question says, then it says Hawthorne is halfway between Tonopah and Reno. So this point right here. So the question is ultimately asking, what are the coordinates of Hawthorne? In other words, how far north and west is it from Las Vegas? So what we in effect are finding is a midpoint of a midpoint. In other words, if this is the midpoint of these 2 points, and this is the midpoint of that and that, what is this? So we have to find this first, and then find the midpoint between Tonopah and Reno, which is what we're going to do. And that will happen sometimes. So here is our formula for midpoint. Our midpoint would be x1 plus x2 over 2, okay, which would just be negative 248 over 2 because that's 0, 0. And y1 plus y2 over 2 would be 232 over 2. So our first midpoint, Tonopah, is negative 124 comma 116. I already had that labeled from where I did this lesson before, but that's how we found it. We found it by finding the midpoint of these two. So, but the real question is, what is this point? So now all we have to do is find the midpoint between these 2 points. So I called that the new midpoint, and we have new x1 and x2. Our new x1 is negative 124. Our x2 is still Reno, because we're finding the midpoint now between Tonopah and Reno. Y1 is 116, the y value of Tonopah. Y2 is the y value of Reno, how far it is from Vegas. So we're going to do x1 plus x2 over 2, y1 plus y2 over 2. x1 plus x2 is negative 372, and then 116 plus 232 is 348. So negative 372 over 2 is negative 186. 348 over 2 is 174. That's our second midpoint. So to go back and answer the original question, it'd be negative 186, comma 174 would be the midpoint of our midpoints. Negative 186, comma 184. I didn't label it before, but I'll label it now. Okay. So the final answer is, if we went 186 miles west and 184 miles north, that'd be the midpoint of the midpoint. In other words, it'd be 3/4 way from Vegas to Reno. So there's your practical example of midpoint. And it's doing it twice. Sometimes it's important. Example 5. So another practical example. Let's read this one together. I think it's on the next page. A seashell is floating on top of the water. A fish is swimming 1 foot below it and 6 feet to the left of it. You are swimming and watching the fish, and your head is 4 feet to the right and 3 feet above the seashell. A bee buzzes in front of you around 1/4 of the way from you to the fish. What is the location of the bee in relation to the seashell? So a big part of this is like, okay, you need to plot these points, right? So first of all, we can plot a seashell as floating on top of the water. So our seashell is kind of our point of reference, so we're going to label it 0, 0, because that's where it all began. Okay, a fish is swimming 1 foot below it and 6 feet to the left of it. So that means, whoops, I went to the wrong example. That means that this point right here is negative 6, negative 1, because it's 6 foot to the left and 1 foot below it, so there's our fish. Okay, wrong example. You're swimming and watching the fish, and your head is 4 feet to the right and 3 feet above the seashell. So you are right here, 4 feet to the right and 3 feet above the seashell. A bee buzzes in front of you around 1/4 of the way from you to the fish. So now that we've labeled everything, the bee is buzzing somewhere around here, about 1/4 of the way from you to the fish. Okay? 1/4 of the way. What is the location of the bee in relation to the seashell? So ultimately what we're trying to figure out is this point right here. What is its value? So now that we've drawn this and labeled it, we have 2 points. We just need to figure out the 1/4 way. And again, like the last practical example we did, the way we can do that is if we find the midpoint between you and the fish and find the midpoint of that, that will give you this point where the bee is, which I didn't label, which I'm going to go ahead and do now. So this right here, that's where the bee is where this arrow is drawn. Actually, yeah, it's fine. Okay, so the bee is right here. Okay, bee is right here. If we find the midpoint and the midpoint again, that will give us where the bee is. So, real quickly, our original midpoint is going to be the midpoint between you and the fish, x1 plus x2 over 2, y1 plus y2 over 2. Again, our first x value is 4, our second is negative 6, or vice versa, it doesn't matter. Negative 6 plus 4 over 2, and then it's going to be negative 1 plus 3 over 2. Okay? So the original midpoint is going to be negative 1, 1. Okay? So going back here, this is our midpoint, but to find the quarter point, we have to find the midpoint between that and u. That will give us the quarter of the way. This will give us the B's location. So now we're going to find the midpoint between -1, 1 and 4, 3. So it's going to be -1 plus 4 over 2, 1 plus 3 over 2. That's 1.5, comma 2. That will be the B's location. So the B is at 1.5, comma 2, and we'll go ahead and label that, and that will finish this problem. So if we wanted to answer verbally, actually, we would say that the B is 1.5 feet above, 1.5 feet to the right of the seashell and 2 feet above it. Pretty simple, right? Okay. The next example is probably the most complex one. I'm going to explain it to a T. If B equals -1, -4, and that's the midpoint of AC, and A equals 3, 5, and then what is the value of C? Well, let's go ahead and plot these points. So if B is -1, -4, that's going to be, wait a minute. Why did I plot 1, -4? Okay, so let's just say it's 1, -4. I guess I typed it wrong there. Alright, if B is 1, -4, and it's the midpoint of AC, and A equals 3, 5, then what is the value of C? So here's B, 1, -4. It says that it is the midpoint of AC. So, and it says that A is 3, 5. So what are we trying to solve for? We're trying to solve for C. Okay? So it's kind of crazy because we're given the midpoint and we're given one of the endpoints. How do we solve for C, the other endpoint? Well, guess what? We're still going to use the equation for midpoint. It's just that we're solving for the endpoint. I'm going to show you how to do that. So when we label our points, 1, -4 is our midpoint. 3, 5 is the first point they gave us. We're solving for the second point, C, which we will call x2, y2. Now the formula for midpoint is the same. Okay, x1 plus x2 over 2, comma y1 plus y2 over 2. The difference is we are plugging in the midpoint this time. That gave us 1, -4. We're plugging in our x1 plus x2, although we're solving for x2 this time, so we're leaving as x2. We're plugging in our y1 plus y2. Again, we're solving for y2, so we leave it. So up until this point, we have two different equations, actually, okay? The x value of our midpoint must be equal to this, right? Because that is our midpoint. So 1 is going to be equal to 3 plus x2 over 2, because going back to the original equation, this is our midpoint equation. And they already gave us the 1 value of the midpoint. So 1 equals that, and -4 is going to be equal to that. So we have two separate equations to solve. The way to solve the left one is multiply both sides by 2, first of all. And the way to solve the right one is to also multiply by 2. So we're going to multiply 2 to both the left and right. On the left, we get 2 equals 3 plus x plus 2. The 2's cancel. On the right, the 2's cancel. 2 times -4 is -8. That's equal to 5 plus y2. To solve from here, to solve for x2, we subtract 3 from both sides, and we get -1 equals x2. On the right, to solve for y, we subtract 5 from both sides, we get -13 equals y2. And that actually answers our question. x2, y2 is the x and y values of our C point, so C is equal to -1, -13. The other endpoint then is -1, -13, and just to give the answer some context, this point that we were solving for is -1, -13, which we can see we got pretty close when we just sketched it. We were pretty close to the actual value of C, -1, -13. So you can do that whenever you're given the endpoint and one of the midpoints. Just plug them into the formula, but you're just solving for the endpoint instead of the midpoint. And here it is, graphed out, -1, -13. This was an app that I will show you in a second that I used to plot this, that I made, that I will link in the description. Okay, I think that's it for this lesson. This looks like this was something else, some other problem we did in class. It wasn't an actual example, I don't think. So that's it. But I do want to show you the app real quick before I close this lesson. This is the Midpoint app. You know, you can play around with this. You can't see my finger moving, but you can touch one of these points and move it around and kind of see why the midpoint formula works. For example, if I just stop right here, I can kind of notate this a little bit. Okay, so let me explain each component of this little app we have here. What I kind of like about it is, first of all, we have this orange value right here, which represents the halfway x value between your 2 points. So it's the average of your x values. So in this case, if you average -7 and 5, you get -1. 5 plus -7 over 2 is -1. The next thing I like about it is it averages your y values. In this case, your first y value is 4. Your second y value is -4. When you average them, you get 0. And then what it does is it puts those together to form your midpoint. So the midpoint actually can be visualized using a triangle, which I think is pretty cool. Again, you can play around with this as much as you want, and hopefully it will help you kind of visualize what the midpoint looks like. You can use a triangle to show that. Alright, so that's it for this lesson. It is on midpoint. If you have any other questions about midpoint, let me know.